All right, so we're gonna move on to 3.7 today. 3.7 is a much shorter, and I would say even a much simpler section than 3.5. Um, so the idea is we're going to transform polynomial functions. So we're maybe shifting them, left, right, up, down, stretched, skewed, reflected, the stuff we've done with really all the functions we've looked at so far. So one of the first things we're going to look at today is I can identify symmetry, and then we're also and transform polynomials. And pretty much it's split into two pieces here. Today we're going to really look at the symmetry part of this, and then tomorrow we're going to look at the transforming of the polynomials. So starting things off here, we have two graphs, and it says look at the graph of f is the graph of f or g symmetric about the y-axis? So you might remember from geometry class or just symmetry in general, but when they say symmetric about the y-axis, that means does the y-axis, is it a line of symmetry? If I folded it out on the y-axis, would it line up on itself? And in this case, absolutely. If you folded your paper on the y-axis, these two graphs would perfectly align with each other. So I would say that f is symmetric about the y-axis. This one's not. If you reflected this on the y-axis, then the graph would look more like this, and it would be in like total opposite spot. So G, definitely no. Then it also says, is the graph of f or g symmetric about the origin? Now, you may have not heard this before, but another way to say symmetric about the origin is 180 degrees as a rotation. So if I rotate, let's look at this graph. If I rotate this graph 180 degrees, which literally would be turning my paper over, the question is, does it look the same or does it look different? And if I turn my paper over, it looks very different. Now it points downward. It's not the same graph at all. But if I look at this one, okay, so notice how it's in the first and third quadrants. If I turn it 180 degrees, it's still in the first, third quadrants, has the exact same shape. So this graph would have what we call origin symmetry, or symmetric about the origin. So here's the takeaway. This has y-axis symmetry. This has origin symmetry. Sorry, there we go. And that's going to be the two main concepts today. We're going to look at graphs. We're going to say which type of symmetry do they have. Part B says graph more functions that are in these formats where n is a natural number. So like n to the third, the fourth, the fifth, the sixth, because this was x squared and x to the third. So saying, what if you go x to the fourth, x to the fifth, and so on? What happens? So let's just take a quick second and do that. Let's look at x to the fourth. Okay, x to the fourth looks a whole lot like this. It's going to have y-axis symmetry. X to the fifth looks a whole lot like this. It's going to have origin symmetry. And what you're going to notice is it alternates. Anytime we have an even degree, it's going to look like this. Okay, it's always going to have y-axis symmetry. And anytime it has an odd degree, it's going to have the 180 degree symmetry. If I rotate this 180 degrees, boom, still the same graph. Okay, so that's the idea here. Is when it says, what are these functions symmetric about the origin? What are symmetric about the y-axis? What conjectures can you make? Basically, we can say that anytime we have an odd power, which would be these cases, it's going to have origin symmetry. Anytime we had an even power, it had y-axis symmetry. And that's a pretty key takeaway from this, because it's going to kind of keep coming up in what we're looking at today. All right. So let's go ahead and read this. This says, a polynomial is considered an even function if it's symmetric about the y-axis, and it's called an odd function if it's symmetric about the origin. So actually what we just figured out is exactly why these are going to be named the way they are as we learn about this today. Even functions have y-axis symmetry. Odd functions have origin symmetry. So graphically speaking, right down here, we have examples of all these. If it has y-axis symmetry, it's called an even function. If it has 180 degree, so again, you rotate this 180 degrees, boom, same function. It's an odd function. It doesn't have to be either of those, though. If it has neither type of symmetry, it's just a neither. Okay? So because this definitely doesn't have y-axis symmetry, it's not the same if we draw a line straight down the middle. Also, if we rotate it, it doesn't look the same. It's crossing in different places than what it was before. So those are our three possibilities here, even, odd, or neither. So the first questions are just that. It says, use the graph to classify the polynomial function. Is it an even, odd, or a neither? So we're just going to graphically look at these, and we're going to say, what's going on? So in this case, if we look at this graph, pretty clearly not y-axis symmetry. If we do spin it, though, we see it looks the exact same. So this one's going to be odd. This one has y-axis symmetry. It's going to be even. This one, no y-axis symmetry. And if we rotate it, notice how it's crossing at 1. If we rotate it, now it's crossing at -1. This one's going to be a neither because it is not the same exact graph when we rotate it. Okay? If you look at the next couple, you should be able to tell right away what types of functions they are. You're looking for the symmetries. This one, rotated 180, that's an odd function. It's going to look the same. This one does have y-axis symmetry. It's an even function. So 2 more examples there of those types. And these aren't bad at all. These are definitely very doable. The next piece to this is saying, what if we don't have the graph? What if we just have the function? Well, here's how these work. If every single power is even, then it's going to be even. And if every single power is odd, then it's going to be odd. So we're going to make a little note here. We're going to say all even powers, then it's even. Kind of obvious. All odd powers, then it's odd. But if it has any combination, so if it has some odd and some even, then it's an either. That's our big takeaway from these. Now, let's start right off with this kind of a tricky one here. So we have an x to the 4th, that's even. And then we have a 5. 5 doesn't have an x on it at all. If it did, it would technically be x to the 0, because x to the 0 is 1, and 5 times 1 would be 5. So in this case, that's even. And 0 behaves like an even, because 0, 2, 4, 6, 8, it's in the evens in terms of numbers. So this is going to be an even function. Now, the beauty of this stuff is, if you're ever not sure, although you are going to be pretty sure because these are pretty easy rules, but if we did just want to graph this and take a look at it, we absolutely can. We can put this in, we can graph it, and we can see if we agree that it has y-axis symmetry. And I would say yes, it does. That looks like the perfect mirror image of itself. Cool. This one, you have an odd power of 3, you have an odd power of 1. So both are odd powers, therefore it's an odd function. Again, just to clarify things, we can graph it and also just visually look at it. But again, we shouldn't need to. The goal of this is that we can identify these really quickly because we're just looking at the powers. But if we graph this one, we should see something that's going to have origin symmetry. So yep, turn this 180, boom, looks like the same graph. Okay. All right, let's wrap up these last couple. This says function odd, even, or neither. This has odd power, even power. As soon as you have any mixture, it's a neither. If you want to graphically see why, we can do that. So 7x to the 5th minus 2x squared plus 4. This should have neither type of symmetry. And I would agree with that because definitely no y-axis. And if we rotate it, it's not crossing up here. It's now crossing down here below. So it's not the same graph. So yeah, definitely a neither. And this one, even power, x to the 0, technically even or behaves like an even. So this one is going to stay even. And again, you can check that graphically if you wanted to as well. And that's it. Just introducing those concepts of odd and even functions. You should be able to identify them graphically and from their equations. And if you can do that, today probably pretty easy for you.